All right, today we're going to take a quick look at a couple of different ways to wirelessly communicate with Arduinos, and we're going to do a very basic radio transmit and receive project using what's called a Yagi antenna. I'm going to show you that in a second. I do want you to know we're talking about like really simple, straightforward, sort of one frequency radio transmission in the build project here today. But I want you to know that you are not limited to the ways in which you can wirelessly communicate between multiple Arduinos or between an Arduino and another laptop. Just really quickly, this is one type of radio module. It's called an XB. Sometimes you'll hear people pronounce it Zigbee. It can be programmed to talk to another single Zigbee, or in some cases, a network of Zigbees, and it's programmed via USB. Let's see if we can get some focus on that. The same USB that is mini B, I'm told, and that is a socket that the Zigbee radio fits into, and there's a programming interface. All of this is in the data sheet for the hardware, of course. And if you look around, you can also find some boards that are designed just to hold the Zigbee chip. So this is essentially yet another Arduino chip, or Arduino board rather, and it has a socket in it that the Zigbee plugs directly into. They used to call this the FIO, and now it is called the, I don't know, something. It just says Spark Fun. It's designed by Nathan Seidel and Leah Beakley. Leah Beakley is also the designer of the LilyPad Arduino. And last but not least, this is a Bluetooth module that is really meant for remote control of Internet of Things devices. This is from Red Bear. It's called the DAP Link, and this is a Bluetooth module that can be connected to an Arduino project to make it wirelessly controllable and even controlled via an iOS app. If you're interested in that, dig deeper, look further. Okay, what are we working on today is this awesome thing. So this is a Yagi antenna, or a Yagi-Uda antenna, named for the inventor. And essentially what this does is we have a transmitter circuit here at 433 megahertz. This is, you should have this in your parts. And this is the receiver for the same radio frequency. All we're doing is writing a little bit of code that when this button is pressed, we transmit a signal from here to here, and it is made audible by this speaker that's plugged into the audio output for that same chip. The rest of this stuff is a pretty simple, obvious kit of parts. This is our cool laser cut handle designed at Building 61 by Adam Watts. And obviously these are tape measures. So the tape measures are part of the Yagi antenna design. The lengths are very specific. The spacing of them is very specific to the frequency that we're trying to receive, which again is 433, sometimes you'll see 434 megahertz. Just depends on if you start counting from zeros or one. And so we'll go through the build part of that. But for starters, well, let's do a little demo. So I'm just pressing the button, and I've written the code sort of like a blink. It is just pulsing for 200 milliseconds and then pausing for 1 second. Now, here's the cool thing about the Yagi antenna. It increases the range, but it also makes this a directional, or it is a directional antenna. So you see, as I steer away from the direction of the transmitter, I am losing signal. And if I bring it back and head on to it, I hear a stronger signal. And similarly, if I'm not pointing at this thing, I don't really hear it well. And that is an interesting, basic way to do some, not just transmitting and receiving, but actually tracking an object, tracking an object's position. We're going to get more and more into that, particularly if we do something like, I don't know, launch a high altitude balloon. All right, before I can build my receiver circuit, and this is the receiver side of the radio, pretty cool, 8 pins, which we'll identify by using the same data sheets. Before I can build that circuit, I run into a pretty common problem for any Arduino project where you're trying to, particularly if you're trying to breadboard components, and that is I need these wires and these wires and these wires to plug into a breadboard. Now, fair warning, everyone will try to shortcut this. If you try to just put one of these wires into a breadboard, one of two things happens. Usually just smash the wire to pieces. The other thing that happens is this is quite loose and you can get a bad electrical connection. And so what we do for wires like this is we strip a little of the end of them off and we add a header pin to it. When I say add, I mean we solder. So we're going to get a quick look at our first soldering project here. If wires need to be trimmed a little bit more, highly recommend this type of a wire stripper. It's quite impressive. It's a little machine. You place the wire in there, it pinches down, and it pulls just a little more, I don't know if you can see that, a little more of the casing off of the wire. So we've got a little bit more room to work with for soldering. Once again, boom, that fast. Love that thing. All right, I'm going to twist those up just a little bit, and I'm going to turn on my iron. If you don't have a soldering iron, be careful. There are several types out there. They are pretty inexpensive. I am not a brand rep, but this Hakko is one of the better ones you can get. Not too shabby. I'm going to cut my pins. I know I need just 2 pins for my coax cable, my 2 more for my battery pack, and 2 more for my speaker. A word about the coax cable. This is a pain in the butt to make. It requires some very careful removal of just the outside casing, the black casing on the outside of that, because just inside the black casing is shielding wire, and that's the way that usually signal transmission wires work, because you get a cleaner signal, which actually travels through, in this case it's a solid wire. So the process of building this part, which we may or may not have provided already, is to very, very carefully strip this black casing off. You can take this braided shielding wire and sort of twist it into a wire of its own, and then we have to cut the additional casing, this white casing, off around the wire. It's a pain, so I did that ahead of time. I'll make another short video about how to get this cable to this stage. Right now, all I need to do is solder a couple of ends of these pins to it. Normal wire clippers. There's a little notch between the header pins. I'm just going to separate them out. You'll use header pins all the time. They plug into your Arduino, they plug into the breadboard. And they're sort of also a nice way to just make a little break in a connection that can be easily taken apart and put back together. I use them constantly. You want to have kind of literally hundreds of these things laying around. Anytime I'm soldering a wire onto a wire, the first thing I do is sometimes it's referred to as tinning. It's just covering. I gotta grab my solder. It's just adding a tiny little bit of solder to the tip of each wire first, and then typically the process of getting this little tiny thing to stick to that thing is, for me, it's easier. So I'll show you how I do that. First of all, soldering irons. Let's talk about them. They do not work unless they are clean and shiny on the end. I'm trying to get some autofocus here. So that's not the shiniest, it's not the cleanest. There's a couple of different things we can do to clean that up. And this container is, it's sort of this, it's a mild acid really, and it will melt and kind of bubble a little bit and clean off any impurities that are on the tip of your soldering iron. You can see it kind of bubbling and steaming there, yum. And then this is a brass wool on the inside of this, and I'm just scraping it. You can kind of see it poking out the back here. Anytime I'm soldering, and this means every time, between every single point that I solder, I want the tip of that soldering iron to be quite shiny. It's almost chrome-like. And if I take my solder at that point and just add a little bit to it, you see a puff of smoke, and you can see like the liquid solder is actually sitting on the tip of that. So now I'm gonna zoom the camera way in there and see if this films. So what I'm aiming for is just this little bit of wire, for starters. When you're soldering, you need to heat both sides of anything that you're connecting, and the solder will kind of flow towards anything that's heated, because that's what solder does. It makes it happy. It goes with the flow. And you can see that wire is not heating super well, and I actually just like lost a drop of solder on there. I should be doing this on some kind of a pad or cover on the table, but I'm crazy. Oh, this wire's gonna be stubborn. You want to be covered with solder. Might have to break out some big guns for this. Yes, if you're wondering if that burns, yes it does. There, I think some's flowing in there finally. So it's literally wicking into that wire. It's just kind of soaking right in there. I'm going to take just a little bit of solder and add it to this pin, heating the pin from the bottom, and then boop, just pops right on there. So the solder is only going to flow in the places where you heat it, and this is going to be the extra tricky part. Try to line these up. My extra helping hand here. I'm going to heat this from the bottom. As heat rises, I'm going to put a little clean solder on there. And I think I got it. Got it. Okay. So it's not a super good connection, but electrons are very small. They will flow across that space. Okay? So I've got to do that on this end of this wire. Since that braided wire takes a little more time, I'll demonstrate one more, and then you're just going to repeat this process for every bit of the wire that needs a header pin on it. This should go a little faster. Clean. Clean. Pin. A little bit there. This is always the worst part. If you trust somebody really well, honestly, the fastest way to make this kind of thing happen is for one of you to hold and the other one to solder. It will be a defining moment in your relationship. You either establish further trust with someone or you burn them. One more. And then I will finish this up off camera. Just want to repeat the process. So I've already added some solder to that side. Clean this. There we go. A little more. All right. And oh, no. There we go. That's a clumpy one, but strong. So I need to do this all the way around. I want to put some pins on the ends of these wires so I can plug them into a breadboard circuit and or the pin sockets on an Arduino. All right, I'm going to finish that up. Okay, let's start with building the transmitter circuit, and that needs to come from the Arduino. So we're going to use our 434 radio transmitter, a button, and just a couple of jumper wires. And I'm going to use some of my fancy pre-cut jumper wires just to keep this as tidy as possible on the screen. For starters, want to pretty much always use this split in the breadboard, which we've explained is an electrical break, and the button's going to go on either side of that. Purpose of that button being, oh, bent that. Let's get another one. There we go. Red, better. The purpose of that split being to separate electricity, and the purpose of the button being to connect electricity. There we go. So see, it's kind of going on either side of that electrical break. And I want to take the transmitter. It transmits from the little hat there, and put it pretty close, but otherwise arbitrarily next to the button. We're going to jump some wires over towards that button. Okay, now, really important with any kind of component like this to understand what each of these pins does. So I'm going to go over to this. So here's the purchase point from SparkFun for that same item. You'll hear me talking about data sheets. So next to any of these items, pretty much everything that SparkFun has, you'll see a list for documents, and you'll see this term data sheet. If you're not familiar with it, it is what it sounds like. It just tells you all about this component. And honestly, probably more than you'll ever need to know. But if we scroll down, we'll see that there is the pin assignment. The first pin, as ordered in the illustration, is ground. Second is the data in, which will be our signal coming from Arduino. Power, obviously. And then ant, because it's very small. No, just kidding. That means antenna. So you can extend the transmission range by adding an antenna to this. Okay, next thing we want to do is connect ground to one side of the button and also the ground pin on the radio transmitter. So I'm going to try and do this as efficiently as possible. Ground pin is there. And either side of the button. Pushing there we go. So up close you can see my button and the ground pin of my transmitter are now connected, and I'll be jumping obviously ground from the Arduino over to that. And the next button is really just want to give it some power. And to keep this clean for the time being, I'm going to use another one of these. Let's check which pin it is. It's the third pin, so back to here. 1, 2, 3. And I'm just going to bring that a little closer to where my ground input will be. Smash that in there like so. Good to go. Oh, there we go. How's that? Better. Okay, on the Arduino side, obviously ground. Now that's connected to one side of the button and jumping over to the ground pin on the radio transmitter. So now I've got ground to my circuit. Next, 5 volts, 5 volt power, and I'm just going to jump that over to the row that is shared with the little red wire. Okay, so I've got power and ground going to the button and the transmitter. Now I've got to look at the signal. And to really understand the signal, we need to look at the code. So opening up Arduino. And oh look, it just happens to be right there. So this is our 433 transmission like button controlled code. Let's just go through the code a little bit line by line. I've already got it commented because I'm a good human being. In the setup, we're declaring a pin mode, which is set to pin 4, and this weird thing called input pull-up. What does that do? It essentially creates a digital switch, and we'll see how that is monitored in an if statement below. And then pin 9 is just set to output, and pin 9, because it's a PWM pin, again we know it's PWM because of the little tilde in there. You see it? You're hiding. Focus. Focus 9. There's 9 right in there. Okay. Back to the code. I'm going to say in the loop, if you digital read, meaning we're monitoring ones and zeros, highs and lows, ons and offs. So we're looking for pin 4 to be low, and that will happen when the button is pressed because of the circuit design. It's going to send a signal. This is like digital write sort of, but tone is a function that has what we'll call, we know it's a function because all functions in Arduino are orange, and a function always has a number of what we call arguments. So if I was a function, I would say I have pretty much infinite arguments. Tone has 2. The first argument is which pin, and that's pin 9, our output pin. And then the second is 440, which I don't want you to get confused as being related to the 433 megahertz transmitter. 440 is actually a tone, and we'll change that tone just as an example in the code. So it's going to tone on pin 9, 440 megahertz, and then it's going to delay, and meaning keep that tone on for, let's see, 1/5 of a second, 200 milliseconds. and then it's going to no tone or just shut off and delay for 1. And this is an if-else statement. So if the button reads low, make the tone. Else, meaning under any other conditions, the button is not pressed, just simply no tone to pin 9. Send no signal. All right? So I also know that I need pins 4 and 9 to be plugged into my circuit. My input pull-up is going to my button. Let's do that. So pin 4 on the Arduino. 2, 3, 4. Is going to go to the other side of the button. So this is the button that's basically just sending an electrical connection to pin 4, and so it's acting like a pin 4 in this case is acting like a button as well. It's just watching that state to switch. And then our other wire, a signal wire of a different color, just to keep it not confused. I'm going to go back to my data sheet, double check. I want my data in to go to pin 2 on the radio transmitter. So that's here. And here. And I've just got my wires kind of curled up there, y'all, to keep things a little less visually busy, but real simple circuit. That is the transmitter. Now, next, we're going to put together the receiver circuit. Okay, we are back. I've got my little jumper pins, I'm sorry, my header pins soldered onto my wires. This is a different wire than the one that I had in the previous video. We figured out just in the nick of time that the stuff I was working with the solid core is not what we actually want. And so I do still have my 2 pins soldered onto one side of the coax cable. This is the shield, which will go to ground, and then this is the antenna connection that will go onto one of these pins. And then on the other side, I actually just want twisted, but no header pin on that wire. So that is a really specific piece. Again, this is probably the hardest thing about this whole project, but it makes it work so well. So let's start by putting together the radio receiver pin. You can see the little receiver antenna coil on that side. You want that to, essentially be facing outward. And so I'm going to put it on my mini breadboard right on the last row. And I need to make some electrical connections. Let's go back to the pin map in a second. There we go. So I need just ground, linear output, not digital output. I need both powers or voltage input. That's pins 4 and 5 here in the middle. And these 2 grounds jumped together. Show you what that means in a minute. And then this is where my coax cable antenna connects out onto the physical arms of the sort of the antenna array. So back to here. Pin 1 is ground. So I'm gonna anticipate trying to connect as few wires as possible, all of my grounds. So I'm going to kind of bring that out towards the middle. And back to my pin mat. My other two grounds are pins 6 and 7. They're underneath the antenna coil, the built-in antenna coil. So they are over here. I'm gonna go to 6 because it's the shortest, and see if I can get that wire to share a row with a herring. Oh, got it. Just got it. Okay. I don't like it. See how that wire is not really quite down in there? I'm going to make a little custom length wire. Here's how you do that. I'm going to take a piece of solid wire here. Got more than I need there. So that goes to 6. And I need it to hit that row right there. So I'm just going to put my finger right about where I need the wire to be bare. Take my clipper, clip off about 1/4 of an inch past that point. Take my awesome wire stripper and just go boop. Custom jumpy wire. Got it? So now 6, more than enough room to share a row with the other ground wire. Okay, there's that. And now the world's most adorable jumper wire. Isn't it cute? Put that between 6 and 7. Might actually be a little too long, and it's probably going to be easier if pull that guy up. Oh no, it's so small. Where'd it go? Well, poo. I'm going to make another custom wire. Question mark. Really short. This might not want to work perfectly. Yeah, it's going to do that. So the casing just slid completely off. I'm trying to push the casing I want back on. There we go. Take that, universe. Try not to lose this time. 6 to 7. Awesome. And there's my radio receiver. Great. Okay, time for some power wires. Back to pin mat. I need voltage to go into pins 4 and 5. They are the interior 2 pins, or the 2 pins closest to the middle of the circuit. Connect that with some reds. I don't have any really short reds, so I'm gonna make 2 more custom wires. And I want that to go, I'm gonna put that in the row directly to one side of ground. There's that. Hate when that happens. Voltage. one wire. Man. Not today, I guess. Slide that back in there. Alright. I think we can work with that guy. 1, 2. Voltage. And you'll fit right there. Lovely. Okay, so nice and tidy. I like that. Time to connect a couple of the other wires. So back to the pin map. I need now to connect my linear out and my ground to my speaker cable. So this is important. Do not get this backwards. Ground, black wire on the speaker, shared with ground in the entire circuit, and linear out, this is what makes the sound, is pin 3. So very careful there, do not get those mixed up. It will damage this board beyond repair and pretty much instantaneously. Fortunately, they make more. There's that. Now my antenna, my coax antenna is going to plug, the shield wire is going to plug into ground on 7, and the signal wire is going to go into the antenna pin, which you see here, sorry, is pin 8, last pin, outermost pin. So that goes in. Work together now. Excellent. All right, batteries are going to go in other side of the board. Black wire to ground, red wire to power, and obviously we'll need to add 4 AA batteries to that. Let's take a quick break here and see if our transmitter and receiver are working in the most basic way. All right, cool, here we go. I've got the transmitter circuit that I built first connected to my Arduino, and my Arduino is plugged in so that I can upload my sketch. I got batteries in my receiver, and that's all it's doing right now. Obviously the coax cable, it is an antenna, but it's not really helping that much, or it shouldn't anyway, and we'll demonstrate that. Let's jump over to the software. I've got my board selected and my communication port open. I'm going to click upload, see what happens to my board. Again, I'm watching for a little transmission receive there. Now, if I hooked everything else up right, when I press the button, I should hear, aha, it's very faint, very faint. If I move the antenna coil like literally a centimeter away from the transmitter, I'm getting a little bit of a beep there. Now, this is exactly what we're trying to demonstrate. The Yagi antenna not only focuses the reception of the signal, but it extends it. So when this is done right, after it's assembled to the Yagi, we'll be able to probably read this over 20 feet or so, whereas right now, honestly, we're getting a weak signal at about 8 inches there. So we've got our circuits built. Now it's time to put the Yagi antenna itself together. Okay, awesome. This is the laser cut Yagi antenna holder, just in its constituent parts. Real simple. 2 pieces like that. This one doesn't fit particularly well. Good spot for a little piece of tape or something, some hot glue maybe to hold that together. Now, the other obvious part that needs to be customized is each of these antenna links. So we have a handy dandy little template guide for you here. These links are actually very specific for a reason. This Yagi antenna is tuned for exactly the radio frequency that we're working with today. So 304, 355, 310, as close as you can get them. And then these drill points also need to be lined up as close as possible so that when we assemble this with the rest of the frame, we've got the right length in each of our the arms of the antenna array. So I'm just going to go through making one of those so I don't bore you to death. We're going to take a really inexpensive 1/2 inch tape measure, and I'm going to do something crazy here. I'm going to pull all of the length of it out because I'm about to cut the catch off of it, and if I don't cut it from the full length, it will just hide inside this case forever, and they're impossible to open. They're not impossible to open. We do it with the screwdriver. There you go. That's the fun, scary part. Let's get rid of that. I'm just going to make one 304 length right now. And I'm going to cut right at the mark. Let's see, 3/16 of an inch before 133. My 10 snips. 1, 2, 3. And cut that square. Great. Success. There's my 304. I'm going to mark with a Sharpie where my hole needs to be. Right there. Do not drill into the table. I've got to get old-fashioned hand drill driver here. Should not be that hard. It will want to kind of ride up that edge, and be careful when you're done with that. You get a little sharp curl of steel there. If you're careful with that, you won't have to grind them off or anything. So there's how to make each of your antenna parts. Let's go back to assembling the frame. Such a thoughtful design by Mr. Adam Watts at Building 61. This tells us this is where our 304, our 310, and our 355 go. I'm going to start with 304. And I've got these really handy little broad head, flat, wide screws. That's going to be even more important here in just a second. Driver bit. Carefully. So I also don't want to go into the table here. Get this started. get my 310s. Actually, I'm going to do my 310s last because I need to get connected to the coax cable, the antenna. So this is a good example of a couple of things in terms of fabrication related to your Arduino projects. You don't need a fancy laser cut thing like this. This is just super convenient, and it's built for speed. This could literally be anything as long as it holds these antenna arms in this relationship. It doesn't have to be this super slick laser cut thing. Atom is just a show off. I'm saying that because I think you can hear me. All right, my two sides of my 310. I need to bring this coax cable back, and kind of want to curl this underneath. This is why we have these specialty broad screws. I want to hook that underneath the head of that screw before I tighten it, and then do the same thing on the other side. Got to pinch that, and this just makes an electrical connection between the two. Nope, nope. And I'll point out another detail. This is a little tricky. Excellent. So another detail about just the 310s, because they need to make an electrical connection, we have sanded off the paint on the tape measure right there so that you get a good electrical connection. We'll do that with a Dremel, and I'm not going to demonstrate that right now. Here. Here, just get it started. Tuck that underneath. Awesome. Awesome, awesome. Now, my coax cable is nice and secure on there, and I can bring that back to the next piece of the assembly, which is my circuit board. I'm gonna bring this up. So these do come with an adhesive back on them. You can peel that off and use that to stick this on. I'm gonna be fancy a little bit and use some Velcro actually with two-sided adhesive. I'm just gonna lay that right through the middle. You can do this same thing by tape, hot glue, whatever suits you. A piece for my circuit board, a piece for my speaker, and that third piece for my battery pack. Yup. And you. And oh, look at you. Look at you. You already got one. Such an overachiever. Battery pack. Right. So now, nice and easy. Circuit board. Might want to adjust the position of that to allow the coax to go back into 7 and 8. Make sure, again, the shielding wire, that's the sort of the wrapper wire, goes into 7. And the center wire in that goes to 8. Tuck my speaker in right there. my battery pack in right there. So cool. I love these things. And you'll never look cooler walking around campus than you will with your own Yagi antenna. Get my handle back in there. All right, this is powered. It's put together. Easy peasy. Let's see if it's picking up our signal. I'm going to back it out here as far as the camera will allow me to go and hit the button. Pretty good. I'm going to rotate it out. Okay, I'm getting some good bounce off of that radio signal, so it's still picking up there a little bit. But effectively, what we've done is increased the range that we can pick up this Yagi antenna. In fact, we're so close here, I can't even really get away from it. I'm not going to move a bunch of cameras around and stop that. I'm going to show you one more thing back on the code side of things about why we're getting the tone that we're getting. All right, so back to this line of code. Let's play with this frequency and just see what happens. I'm going to sort of randomly say 1200. Upload this. And it's a simple and interesting effect, but it's also going to give you a little bit of a clue about how to make sound using Arduino. So, same thing, totally different tone. So all we did in that tone code is change the frequency of the tone coming out. So that's coming out of the PWM pin. We talked about what that looks like. It's sort of like just switching on and off at exactly the right rate to produce that tone. Let's go in the opposite direction. We were at 440. Now we're going to go down to, let's try half and start to just see what's happening with these tones. And then take one more look. Uploading. Done uploading. Okay, really low frequency there. So, interesting. Also, just not transmitting quite as far. Back to the code. Just want everybody to be clear. This value, the second argument in the tone function, is a list of frequencies. Curious. Could you transmit the Imperial March from your 433 radio transmitter to your 433 radio receiver on your Yagi antenna? Maybe you should try doing that.